Although the James Webb telescope has only been in operation for 2 years, it has already caused quite a stir in the astronomical research world. But how can we explain the early galaxies discovered by Webb, which completely overturn our current theories? And what about the confusing deviation in the cosmic expansion rate that has always left researchers baffled? Well, who knows? Perhaps these impossible discoveries are the result of merging with other universes. Because what at first sounds like the plot of a wacky science fiction movie is actually the core of an official scientific study that was recently published, and which could lead us straight to an incredible discovery. The view of the starry sky at night is simply overwhelming, and yet in the same breath, it also raises a simple yet profound question: where does it all come from? In other words, how did the universe, with its gigantic diversity, come into being in the first place? Well, while the inhabitants of the past mainly referred to divine creators in this regard, modern scientists take a slightly different approach. By observing other galaxies and measuring distances, experts have drawn a conclusive picture of the birth and development of the cosmos in recent decades. And according to the Standard Model of Cosmology, it all began around 13.8 billion years ago when space, time, and matter emerged from an unimaginably dense and hot singularity. In detail, however, the Big Bang not only paved the way for the unfolding of the universe, it also set in motion a process that continues to this day: cosmic expansion. To explain the observed accelerated expansion of the universe, the mysterious dark energy has again been invoked, although its existence has not been directly proven experimentally, and its physical interpretation is largely unexplained. And yet, our understanding of the universe today is more precise and comprehensive than ever before. But what if this is simply not true? What if our basic cosmological assumptions are simply no longer tenable due to new discoveries? Well, this is precisely the question that astronomers are inevitably confronted with at the moment. Because, as you have probably noticed, the James Webb telescope has already detected several structures that, according to our theories, should not exist in this format. All this applies in particular to the impossible galaxies, which were already formed in the early days of the universe and throw our models into chaos with their astonishingly large masses. In detail, Webb has identified 6 galactic precursors whose light took more than 13 billion years to reach our terrestrial eye, and which, despite all this, were already almost as developed as our Milky Way today. Since, according to our understanding, there was simply not enough normal matter to form such massive associations so soon after the Big Bang, this unexpected discovery calls into question our entire picture of early galaxy formation. And the subsequent discovery shows that this is by no means a confusing isolated case. With GSC 140, Webb added another early galaxy to the star charts that existed as long as 290 million years after the Big Bang. However, the Space Telescope not only provided experts with a new record-breaking galaxy but also another agonizing puzzle. The experts' analysis revealed that GSC 140 must have already contained several hundred million solar masses of stars. Furthermore, the presence of oxygen in the emission lines suggests that several generations of very massive stars must have gone through their life cycle before the researchers observed the galaxy. In view of this, the common image of an early cosmos that only contains small, very faint galaxies seems to be outdated. But in truth, these so-called universe breakers are by no means the only cosmic curiosities that Webb has already given us. In fact, the most powerful space telescope of all time has also confirmed a number of unexplained discrepancies in the Hubble constant that have been giving scientists a headache for several years. The mystery of cosmic expansion deepens. If anyone knows about the expansion of the universe, it's Adam Rees. After all, the U.S. astrophysicist was awarded the Nobel Prize in Physics in 2011, together with Saul Perlmutter and Brian P. Schmidt, for the discovery of accelerated expansion. However, the renowned expert can be quoted as follows regarding his latest research series. "There is a real and exciting possibility that we have misunderstood the universe. And in order to realize what this profound statement is all about, we must bear in mind that, contrary to all expectations, the expansion of the universe is not uniform everywhere. In fact, the universe seems to be expanding faster in our cosmic neighborhood than in other parts of space, which strictly speaking, should not be the case. The driving force behind the accelerated expansion of the cosmos is dark energy, which is supposed to counteract the gravitational pull. How fast the universe is currently expanding is, in turn, indicated by the Hubble constant, a parameter in Einstein's field equations that describes the rate of expansion. Adam Rees explains that he and his colleagues can predict this expansion rate by measuring the cosmic background radiation and then using the theoretical models of cosmic development to determine the current expansion rate. This results in a Hubble constant of 67 km per second per megaparsec. At the same time, however, it becomes extremely confusing at this point. If we now use a different measurement method, the value for the Hubble constant is suddenly completely different. In other words, if we determine the Hubble constant on the basis of supernovae, red giants, gravitational lensing, and variable stars or so-called Cepheids, we arrive at a result of 73 km per second per megaparsec. In other words, the universe is expanding faster than it should be. But how is this even possible? Well, the simplest explanation is based on the assumption that the discrepancies result from a combination of measurement errors and inaccuracies. And to check exactly this, the team around Rees used Webb's near-infrared camera, an IRCam, which then took a close look at over 320 Cepheids in several galaxies. As many of these stars had already been targeted by the Hubble Space Telescope, the re-examination enabled a comparison to be made and ultimately revealed that the Hubble data was correct. This means that the new Webb data sets also yield a Hubble constant that clearly exceeds that from the theoretical models. But why is that so? What is behind Adam Rees's statement that we have misunderstood the universe? Well, in detail, the Nobel Prize winner means that there could be a process, or a force behind the faster expansion of the cosmos that has not yet been taken into account in the standard cosmological model. This could possibly be an exotic form of dark energy, or dark matter. Alternatively, our understanding of gravity could be flawed, or there could be novel particles or fields out there that are completely unknown to us. The merging of the universes. The bottom line is that these are not the only theories to explain the Hubble discrepancy. For example, the so-called intelligent design movement argues that certain characteristics of the universe are best explained by an intelligent cause, given that the fine-tuning of the universe contains clear indications of a kind of conscious blueprint. This group of scientists is therefore open to the possibility of a creator. However, this is not defined more precisely. It is therefore not about the idea of a god, but rather about the scientific examination of the thesis that the complexity and order of the cosmos point to a superordinate design and plan. Another hypothesis, presented in the Journal of Cosmology and Astroparticle Physics, is as exciting as it is unorthodox. The reason for the deviation of the Hubble constant could be that our universe is merging with other universes. This approach, therefore, moves away from the idea of the ominous dark energy, which can plausibly boost the expansion of the universe on paper, but whose actual existence, as mentioned, has not been proven, and where the fusion of cosmic worlds is considered more likely. Physicist Jan Amjorn from the University of Copenhagen points out that the model based on the fusion with so-called baby universes could explain the collected data even better than the standard cosmological model. The lead author of the study and his team developed a mathematical model to investigate the hypothetical effects that multiple interacting universes could have on our cosmic home. The researchers' calculations showed that merging with other universes should increase the volume of our cosmos, an effect that could be perceived from our measuring instruments as an expansion of space. In the same breath, the scientists also determined the rate of expansion of the universe that would occur in such a scenario. And lo and behold, the calculations based on cosmic unification were even more consistent with observations of the universe than the traditional standard cosmological model. In addition, the new theory also deals with the problem of cosmological inflation. This refers to the phase of extremely rapid expansion of the universe, which is assumed to have taken place shortly after the Big Bang. Until now, physicists have suggested that the rapid expansion was caused by the inflaton, a hypothetical field that drove the ultra-fast expansion in the first milliseconds after the Big Bang. However, the authors of the new study now explain cosmological inflation by saying that our young universe may have been absorbed by a larger parent universe. And if you like, our world then followed in its mother's footsteps. The scientists suspect that our universe continued to collide with other baby universes after its absorption and swallowed them up too. But how could this exciting theory be tested? Might it even be possible to catch a direct glimpse of the baby universes that our ever-growing world is currently absorbing? Well, not quite. The main focus of the experts is currently on microwave background radiation. This almost isotropic radiation, which fills the entire universe and was created shortly after the Big Bang, could therefore have some unexplored properties that may lead us to a groundbreaking discovery in the near future. And we would be delighted if your near future leads you to the subscribe button now. Feel free to press the thumbs up and subscribe to never miss another exciting video from us.